In this third video series about lists, we'll be talking about how to process a list using iteration. At the end of this final series, you'll understand the concept of list iteration, be able to create algorithms that iterate through a list to perform operations on each list item, and be able to write the Python statements to successfully iterate through a list in software. By now, you should be familiar with the concept of a list. A list is a linear collection of items. And we've seen some functions for operating on a list. Python includes lots of these. We've learned about the length function, the sort function, the print function, and also some special list operations like insert, append, and delete. Today, we're going to customize our own algorithms for processing items within a list, rather than being dependent on algorithms that are provided in the standard library. Remember that a list represents a collection of items. And so if we want to process all of the items in the collection, we're going to have to repeatedly perform some action using each of the individual values within our list collection. And the great news is that computers are really good at storing long lists of data. For example, at UMW, we store a list of all students. In your iTunes account, you might store a long list of songs that you have purchased. And in your Netflix queue, it might store a long list of shows that you've watched so that it can create recommendations for future things you might enjoy. Computers are also really good at carrying out repetitive instructions. Human beings tend to get bored if they carry out the same action over and over again. Thankfully, computers don't have emotion, and so they don't mind repeating the same actions over and over again in the course of an algorithm. Let's see an example of how we might want to repetitively process the items that are in a list collection. Suppose that we have all of the students that are in a Computer Science 110 section stored in a list. Let's say there's 10 of those students. And currently we're storing their quiz score average within that list. So here we have a quiz score list, and suppose that that represents each of the individual students' average quiz score. So the first student has an average of 7, the second student has an average of 6, and so on. If we drew out what this list would look like in memory, it would have this appearance. Remember that a list is stored in adjacent memory locations, and that the computer numbers each of the memory locations starting with the number 0, and then going up to the number of items in the list -1. So this particular list has 10 items. That means values are stored at indices 0 through 9. The first item in the list, the 7, will be stored at index 0, the 6 will be stored at index 1, and so on. The 8 will be stored at index 9, the last position in the list. Now suppose that we want to see what would everybody's quiz score average look like if I added extra credit to everybody's quiz average. We could process the items in the list one at a time and print out what the value of the score was after we've added 2 to it. So here's what that would look like in Python. We'd create our quiz score list with those 10 values in it, 1 for each student. And then we would go through and we'd say, I want to print out the value of the first quiz score, the one at position 0, and I want you to add the value 2 to that so that I can see what that would look like. Then we'd perform that same activity for the second student, the one at index number 1. We'd say print quiz score list at index 1 and add the value 2 to it. Then we do the same thing for student number 3, say add quiz score list at index 2 plus 2 and print out the result. Then we do the same thing for student 4, add the quiz score list at index 3, add 2 to it and print it out. And so on. We do that 10 different times for every index from 0 through 9. We'd add a 2 to the contents of that list position and then print it out. That would definitely work. It looks like that would be a little bit tedious and boring to write out because all of the statements are really similar. We'd be tempted to copy and paste. Maybe we'd do like 2 or 3 lines, and then we'd want to copy and paste it to put it in the other lines that we need. And that would work fine. And maybe for a list of size 10, it wouldn't be that bad. We could definitely take this approach. But imagine that we had to do this for a list of all the students across all the computer science 110 sections. There's like hundreds of them every semester. And so I wouldn't want to have the job where I had to repeatedly type out this same instruction hundreds of times to see what somebody's quiz score might look like if I added extra credit to it. It's really boring. It's easy to make typos. It would be easy to accidentally repeat one index twice when you were copying and pasting, and then that person would get double extra credit. It would be easy to miss somebody and they wouldn't get extra credit that they deserved, and so on. So this probably isn't the most effective solution for us to take as a human being. It works just fine in the computer. It's logically correct, but it's probably not what we want to do. So now we're going to learn a more efficient way of processing lists of items, and it's using a technique called list iteration.